Kia ora koutou. This video is going to do questions 4 and 5 from the June 2021 AS Pure 1 paper, and it's paper 1-3. So these are two trig questions. The first one uses some identities and then solves an equation, and then the second one is one with some trig and geometry and stuff. Okay, so in this first one, we've got a question structure where the three parts are all linked up. In the first bit, we have to show that we can take this equation here and rewrite it like this. So in the first one, you can see we've got tan, and in this one, we haven't got any tans or sines, we've just got cosine. And that's your biggest clue for how to start that problem. Then you have to express cos of x in terms of k. So even if you miss this part, you can still do this one, and then you can still do this one, where we have to solve this equation, which looks horrible, but using the first two parts, it's actually a very simple little 2-mark question. So let's have a look at how I set that out, because logical setting out is really important. So I'm going to start by saying that we know that k is equal to tan x plus sine x over tan x minus sine x. Now, when you're doing a proof question, you always want to have one eye on where you're going. So I'm just going to shrink this a bit and go back and see what we're trying to get to. Well, we want to get to 1 plus cosine x over 1 minus cosine of x. So let's just write that somewhere up here. So we're trying to show that k is equal to that. And that's why when I did this, I wrote the k first here to make it more elegant. Now we're going to substitute in sine x over cos x for tan x. And I'll do this using one huge fraction, but then when I clean it up, I'll break that down a bit. Okay, so we've got that divided by that. When we see fractions being added together, we know that we need to get a common denominator. So for that first, the numerator is going to be sine x plus sine x cos x. And then that's being divided by, so we're getting a common denominator now on this bit here. We're going to have a cos x as my common denominator, so sine x minus sine x cos x. When we divide by fractions, we multiply by the reciprocal. So here, I'm going to do a couple of things in one go. I can see that I've got a common factor of sine x in here. So I've got sine x times 1 plus cos x over cos x times cos of x, and I'm going to do the same factorizing here. So cos x over sine x into 1 minus cos of x. Right, so now I can simplify out. We get this and this. We end up with 1 plus cos x over 1 minus cos x as required. So there you go. What's next? Right, the next thing we have to do is to hence find cos x in terms of k. In other words, we need to get an expression for cos x, which has got k's in it. We need to make cos of x the subject. So k minus k cos x is equal to 1 plus cos x. I'm going to gather up everything with cos of x in it. I get k minus 1 is equal to k cos x plus cos x. So we're just about there. On the right-hand side, we have k plus 1 times cos of x, giving us a final expression of cos x is equal to k minus 1 over k plus 1. Okay, so that's my final answer for that question. And then the last bit turns out to be the easiest part in a lot of ways. We're asked to solve this equation here. Right, so we've got this thing here equals 4. So that's just the same as what we had up here, only now we have a specific value of k. But we know from this part here that cos of x is just 1 minus k over 1 plus k, right? So for part C, we know that k is equal to 4. So what we're solving is cos of x is equal to 4 minus 1, 3, over 4 plus 1, which is 5. and we're finding the values of x between negative pi and pi. So whenever you solve a trig equation, you should be drawing a little graph, no matter how simple the equation. So here we're going to draw a very rough sketch of the cosine graph between negative pi and pi, right? So we know that it's an even function, it's symmetric about 0, and you can see from this that there are going to be two values that I want as my solutions. So here and here. So x is equal to cos inverse of 3/5, and in radians that gives me x is equal to 0.927 as the principal value, and then the other one in my domain will be x is equal to negative 0.927, right? So you can see that what the graph is good for is it makes sure that you don't miss any solutions and you don't get any extras in, and you're always thinking about the domain of your function. And for people in 13 MCA, when we get into our work for the level 3 trig standard, you'll see that that is really, really crucial as the problems get more complicated. So now looking at the next one, which is a kind of geometry and trig thing. This is question 5. So if you haven't, pause the video and have a go here. You'll realize straight away that you need two formulae to do this problem. One of them, so let's read it first. We've got a nice diagram, and we've got a triangle, we've got a right angled triangle, and we've got a length of AB of 4. And ABD, so this bit in here, is a sector, and it's part of a circle with centre A. So we know that 4 is the radius for that circle, right? And the area of the sector is 10 centimetres squared. So the first formula that we need to write down is going to be the formula for the area of a sector, and the area of a sector formula is equal to half r squared theta, where theta is in radians, right? So the first thing to do is to find that angle BAD in radians, and then we're going to have to find the perimeter of the shaded region. So it's worth reading through the whole question first, even though it's pretty easy to jump in now and find that angle. So the perimeter of the shaded region is going to have 3 bits. It's going to have this here, which is going to come from like year 10 trig or year 9 trig. And then it's going to have this bit here, which is also going to come from some pretty basic trig, remembering that that length AD must also be 4 centimetres. Then we're going to have to find an arc length for this. And once you've broken the problem down like that, this is not a difficult question at all. Okay, so I'm just going to work here next to the diagram. We know that the area of the sector is 10, and we know that the radius is 4. So we've got 10 is equal to half times 4 squared theta. So theta is equal to 20 over 16. So theta is equal to 1.25. So that's angle BAD is equal to 1.25. Right, so the next thing we're going to do is we're going to find that arc length, and the formula for the arc length is r theta. So S is equal to r theta, which is equal to 4 times 1.25, which is 5 centimetres long. Now, length BC is going to be tan of 1.25. I've got all of the mess from the last question. Sorry about that. Let me just get rid of that. Okay, so BC, so tan of 1.25 is equal to length BC over 4, or you could call it X. So BC is equal to 4 tan of 1.25, which is 12.0383 centimetres, and I'm going to round that later on. Now, two ways to get length AC. You could get it with trig, or you could get it using Pythagoras, and then we're going to subtract off this bit here. So just make sure you're doing some pretty careful labelling. By this stage, you should be confident with using both algebra, so using x's and y's, but also just using the length. So length AC squared, we know, is equal to 4 squared plus 12.0383 squared. So chucking that in your calculator and square rooting it gives us AC is equal to 12.685 centimetres, and then DC is going to be that minus 4. So it's going to be 0.8685 centimetres. So my perimeter is equal to 5 plus 8.685 plus 12.0383 centimetres, which works out to be 25.7 centimetres, and that's to 3 significant figures. Okay, so just a quick comment on that is that you are going to need to use all of that AS geometry stuff when you're doing A-level this year. So don't completely forget about those formulae. They are on the formula sheet, but it's good to have them kind of inside your brain as well. Next video will be later on today, and they start to get a little bit more interesting from about question 6 on. So keep watching.